we have 15 chapters, right? And I hope all of you have gone through the basic introduction that what all are there. Today we'll be, so basically broadly, if you see, broadly we have probability and random variables. In random variables also we have simple random, we have multivariate, and then we have univariate. So univariate and simple are same, and then you have multivariate random variable. You have basic sample moments, mean, median, mode, variance, standard deviation, all those stuff. Then we have hypothesis. So after this, so these are all basics which you need for the higher level topics. So starting with higher level topics, we have hypothesis testing. Again, hypothesis testing, I will not say higher level topic. It again forms a base for our higher topics. Then we have regression. So in regression, we have linear regression, simple linear regression, multiple linear regression. Multiple is where you have multiple explanatory variables. And in that only you talk about regression diagnostics. Then we move to time series. In time series, we have stationary, non-stationary time series. Then again, we move to volatility, correlation, different kind of measuring different returns. Something which you will learn, along the way which you move ahead. Um, After that, you have simulation, machine learning. In machine learning, we talk about simulation, bootstrap methods, supervised and supervised machine learning methods, with predictions and all those. So 3-4 chapters are of machine learning. So broadly, if you see in cons in FRM part 1, you have regression, you have time series, and you have machine learning. These are the 3 major topics. Apart from that, whatever you study is forming your base to, understand the major 3 topics that we are covering. So today I will be talking about probabilities. It is I'm teaching cons part, Vaishnavi, okay, of FRM part 1. All right. Okay. So today our topic will be majorly covering. I will be covering probabilities. I hope my screen is visible to all of you. If you have any doubt, do let me know. Okay. So, fundamentals of probability is what we will focus on today. Now, if you talk about the very basic probability, it's basically when probability is basically the likelihood, all right, of a particular event. Let's say suppose in a bag you have a red ball and a blue ball. So what is the probability, or what is the likelihood, or what is the chance of picking up a black ball from these 2 black and blue balls which are there? Right? So that is the basic definition of probability that we have. Let's say suppose you have a coin. You are throwing a coin, and then what is the chance of getting a tail? What is the chance of getting a heads? That is again a basic concept of probability. We all know that both have equal chances. So you can say that probability of getting a heads is 1 by 2. So here when I write 1 by 2, how do we write this? Basically it's probability. It's the number of times, number of the event concerned, या event A जिसको बोलते हैं, and then divided by the total events possible. So here if I want heads, then heads can come only once, like either heads or tails. So you have just one heads. And what are the total number of events which are possible? Heads and tail, 2 events are possible. Similarly, if I tell you in a bag of 2 black balls and 2 blue balls, what is the probability that if you pick one ball, it's a blue ball? So there are 2 blue balls which are there, and in total you have 2 plus 2, 2 by 4. two black and two blue balls. So similarly, it's a basic concept of probability that you might have studied. Okay. Now in this probability concept, we have basic definitions, basic words. So here when I talk about different events, so you have two words. One is your event and another word is event space. All right. Now what do you mean by events? Events is basically a single outcome or a combination of outcomes that you want. You want a head, you want a tail, you want when you throw a die, you want either two or you want even numbers 2, 4 and 6. So what is the event? It can be a single outcome, it can be a multiple outcome also, right? Apart from that, what is the event space? Event space is basically considering all the events. Event space is when you take into account all the events, that is your set of all the possible outcomes. It is a set of all the possible outcomes. Now let us consider that you are throwing a coin. So throwing a die, let's suppose. Okay? And the outcome that I want is, let's suppose, even numbers. This is my event of concern. I want even numbers. So what are the events? 2, 4 and 6. There can be three outcomes. There can be three outcomes. Correct? And what is the event space? Event space becomes the total number of all the outcomes which are there. All the possible outcomes. These are the total possible outcomes. Here you talk about the concerned outcome. And here you talk about the all the possible outcomes. Event divided by event space gives you the probability of that particular event happening. Is this clear? Okay. For example, if I tell you that I want an event of getting, when I throw a die, event of getting probability, we write it like this, P, capital P for probability, and in bracket whatever probability you want. So let's suppose in bracket I am writing I want even numbers when I throw a die. So what are the possibilities of getting even numbers? Either you can get a 2 probability, either you're getting a 2 or you're getting a 4 or you're getting a 6. So there are 3 events, right? So in total 3 events divided by what are the total number of events? 6. This is the event space. Yes, correct. Okay. Sample space, event space. Understood? Clear? What is event? What is event space? What is probability? Now let's move to another concept that we use in set theory. There are two things. Probability A, U. This U is basically standing for union. The word union. ठीक है? A union B या फिर हम लोग इसको बोलते हैं A or B. ठीक है? The word we use is or. Similarly, we have probability A intersection B, or we call it as A and B. Alright, so this is intersection, this is union. Now what do you mean by this? This means either event A or event B. Probability of getting either A or B. That is what I have written over here. Probability of getting either 2 or 4 or 6. Here I have written probability of all, like probably and. What do you mean by and? And basically means intersection. Probability of getting 2 and 4. Probability of getting head and tail. Alright. These are the two different notations. Now, why are we using these two notations? We'll study the next part. The next part explains the difference. There are some, again, keywords that we will be learning. One is, there are different types of events that we talk about. One is independent set of events. Independent events is what? Independent event is when we say that outcome of one event does not impact the outcome of the other event. So when there are two events and these two events are independent, that means, let's say suppose we have two events A and B. All right. outcome of this is not impacting outcome of B, and outcome of B is not impacting outcome of A. That is what a independent event, set of independent event means. Now, independent events, for example, if I tell you, in a bag, you have 3 blue balls. Okay? In a bag, you have 3 blue balls and you have, let's say, suppose 2 red balls. Now, there are 2 events that I'm defining, event A and event B. Event A is the event of taking out a blue ball, and event B is the event of taking out a red ball. Now, if I take out one blue ball, right, is it independent of taking out one red ball? No, it's conditional. It's conditional on this event, right? For example, the first time so there are 2 things. The first time I'm taking out a ball, and then the second time I'm taking out a ball. Both of these events are independent or not independent. They are dependent on each other. First time you take out a ball, let's suppose you have removed one ball from the bag. You're left with only 4 balls now. So taking out another ball from the bag is now dependent कि आपने पहले क्या निकाला. What did you extract first? Did you extract a blue ball or did you extract a red ball? Right? So independent events are basically probability of one event is not impacting other. In a case where one probability is not impacting the probability of another, you have 2 coins, coin 1, coin 2. You're throwing both the coins. The outcome of coin 1 is not impacting outcome of coin 2. Outcome of coin 2 is not impacting outcome of coin 1. So these 2 events are basically independent events. All right. So when we say that the events are independent of each other, then in this we have 2 relationships. One relationship is probability of happening of event A multiplied by probability of B is same as writing like this. What do you mean by this? That the probability of both A and B that will happen is the product of their unconditional probabilities. These are all unconditional probabilities. Meaning, if I say probability of A intersection B, meaning probability of A and B is nothing but probability of A multiplied by probability of B. Let's say suppose, let's give me an example. I'll give you an example. A is getting head when you throw the first coin. B is getting a head when you throw the second coin. You have 2 coins. You're throwing one coin, getting a head over there, and throwing the second coin and getting a head over there. So you're checking the probabilities of that. So I'm asking you, find out the probability of getting a head in the first coin and head in the second coin. And the word and. So what you are doing, you will simply multiply both and give me the answer. 1 by 2 into 1 by 2 gives you 1 by 4. All right. Clear? This is the probability of getting a head in the first coin, probability of getting a tail in the second coin. Similarly, what's the second relationship that we talk about? This is a little bit complex. Probability A dash B, I will explain you what it means, is equal to probability A. Now, A dash B, this basically stands for probability of A, probability of getting A conditional on B, meaning probability of getting A given that B has already occurred. So when you are calculating the probability of A, it actually means that B has already occurred. So what is this? It's a way of writing a conditional probability. This is nothing but a conditional. Why it's called a conditional probability? Because you're calculating probability of A given B has already occurred. Now, since A and B are independent of each other, so even though B has occurred or not occurred, it will not impact probability of A. That is why this conditional probability is simply, we take it as equal to, probability of A, which is actually, this is actually, we call this as unconditional probability because it does not depend on any condition. It does not depend on any condition. Are you getting the point? Yes or no? Okay. Now let's take the same example. Probability that when you threw the first coin, you already got a head. Find out the probability that when you throw the second coin, you will get a head. Now, throwing of the second coin is not dependent on the first one. So it's simply probability of getting a head in the second coin. Yes or no? Tell me. Is it clear? Is it clear? Quickly a thumbs up, please. All of you, any doubt, please ask. Okay, moving to the next concept. Independent is done. Another concept that these are independent events, okay? And these are the two rules that we have for conditional probability and intersection, or basically we say A and B happening together. Another concept that we talk about is mutually exclusive events. Mutually exclusive events is basically when you say that both of them uh, cannot happen. It's like two events. If they cannot happen together. For example, if I say when you throw a die, getting an even number, which is, and getting 5. Is it possible to get even number and getting a 5 together in the same throw? Yes or no? Can it happen together? Yes or no? It cannot happen together on the same roll. So these are two mutually exclusive events. Mutually exclusive meaning it cannot happen together. If I draw a Venn diagram, it looks like this. This is A, this is B. Mutually exclusive events. If A is happening, this cannot happen. If B is happening, A cannot happen. Any one. Okay? That is mutually exclusive events. For example, I am saying I'm defining that event A is getting an even number and event B is getting a 5. They cannot happen in the same. Got it? Understood? Now, one more general, you can make a note. Probability A intersection union B, meaning probability A or B. Either A or B. I'm asking, it can be B, A also, it can be B also. So how do we write this? Probability of A happening plus probability of B happening. But here we need to subtract one thing, that probability of A intersection B happening. How is this possible? Let's draw a Venn diagram again. Let's say suppose we have two events which are not mutually exclusive. Both are interdependent. All right. The word interdependent is actually wrong. These are not mutually exclusive, meaning there is some common part in between them. I want the probability of A or B, which is this entire shaded part. इसका probability आपको निकालना है. So this is what? This is probability of A plus probability of B. But there might be some common part which you need to subtract. Otherwise, there will be a double counting issue. So you have subtracted A or B. For example, let me give you an example. A is an event of even numbers. 2, 4, and 6 are even numbers. B is an event of, let's say, suppose numbers which are greater than 3. numbers which are greater than 3, which is 4, 5, and 6 when you throw a die. Now I'm asking you, if you throw a die, find out the probability of A or B. So probability of A will be either getting 2, 4, 6. Probability of B will be getting 4, 5, 6. Now the situation is that in both of these we have 4 and 6 as common. So there will be a double counting issue. What you are doing is you're calculating 3 by 6. How 3 by 6? 3 is the total number of events and 6 is the total events. 3 is the events possible, outcomes possible for event A. Plus again 3 by 6, plus you again, since you are doing this 3 by 6 plus 3 by 6, there is a issue of double counting. You are counting 4 and 6 two times. If I draw the Venn diagram, here you have 2, here you have 5, and in the common portion you have 4 and 6. You're counting this 4 and 6 two times. What I want is A or B probability of either getting a even number or getting a number which is greater than 3. How many possibilities are there? Tell me. How many possibilities are there? Listen to the question, getting a number which is even, 2, 4, 6, or a number which is greater than 3. So, which is also 5. 6 and 4 is included. So, this is the set of events that you want. But if you are following this method, then you are double counting. So, you need to subtract A intersection B, which is 4 and 6. So, you will subtract 2 by 6. You will subtract probability A intersection B. That's how you will get your answer. 4 by 6. 4 events, 4 outcomes. Is this clear till here? Tell me. If the events are mutually exclusive, meaning if the events are looking like this, then in such a case, there will be no event where intersection can happen. So in such a case, there is a special case that A or B is probability A plus probability B, because A intersection B is 0. Yes or no? Is it clear till here? Please see. All of you write a yes. Any doubt, please ask. ठीक है? Chalo. Let's talk about the next definition. Next definition that we talk about is conditionally independent events. Again, a little bit tricky, but very, it's easy to understand once you get the flow of it. Conditionally independent events. Now, conditionally independent, here we've talked about independent events, that A and B are two different events and these are two independent of each other. This is basically, we're talking about unconditional independence. Why unconditional? Because we're talking about probability A and probability B. Probability A is a unconditional probability of A happening. Probability B is the probability or unconditional probability of B happening. Do you remember here I just showed you, where is it? This. Here I showed you this is conditional probability of A given B has already happened. So here we are not talking about independent events, we are talking about conditionally independent events. Now let's take an example where we have three events, A, B and C, and I'm taking out probability of A given C. I want to take out probability of A given C and B given C. What do you mean by this? Can anyone just unmute and tell me how do you define this? How do you define this? Unmute and tell me.
Probability of happening, occurrence of A given C has occurred, and the other formula wise A union C, A intersection C by probability of C, and
I
the
don't need
second,
the formula. So it's basically probability of A happening given C has occurred. है ना?
yes.
So now when you have these two conditional probabilities, these two conditional probabilities may or may not be independent on each other. Now this may be or may be independent of each other. This does not depend on probability A and probability B. Meaning if probability A and B are independent of each other, let's suppose that these two are independent of each other. This will not imply that these two events are also independent. No. Here, these two events can be independent or it can be dependent. Even though these two events are independent of each other, it will not imply that these two are independent or dependent. Got it? Tell me. So, we say, ये लॉजिक क्लियर है कि अगर आपके जो ये क्या हो गए unconditional probabilities. So if unconditional probabilities are independent or not independent, it does not talk about the conditional as well. Both are different. So we say that the we say that these are conditionally independent events. When do you say this? When you say probability A given C multiplied by probability B given C is actually equal to probability A intersection B given C. If this is the case, only then we say that these events are conditionally independent events. Got it? Understood? We'll take an example तो उससे और clear होगा. Let's define A. आप लोग लिखो. Event A, let's suppose event A is getting a score above average in an exam. Event A is getting score which is above average in an exam. Similarly, event B the student is taller in height than average. And let's say suppose there is one more event C. So here I'm seeking scores above average marks in an exam, taller above average height. Of students, and let's say suppose C is an event which is, let's suppose, age equals to 8 years. Now let's say talk about only event A and B. If we only talk about A and B, In a class, in a, let's suppose in a, let's suppose class 3 or class 4 students, um, let's only talk about the two events A and B. Now, do you think that event A and B are independent of each other? Scores of students scoring above average, is it dependent on event that taller the student is taller above average? It basically means that the taller students probability, if probability, so when do you say that event A, probability A and probability B are independent of each other? Then probability of A is not impacting B and probability of B is not impacting A. That is when you say that it's independent or dependent. Now you have written in the chat box that it's independent, but I am saying it can be dependent as well. Why? I'll tell you. If probability of A increases, let's say suppose probability of B also increases. What it means is that the taller students in class can be the ones whose age is more compared to students who are shorter. होता है ना बहुत बार एक क्लास में you have seen that students some are of batch, some are born in 1999 and some are born in 1998. Generally, this generally happens. So we are saying the taller students are the ones who are, bigger in age, and that those are the students who are scoring more because they are bigger in age, right? So it can be independent, it can be dependent as well. Both the events. You are saying independent. So we are talking about that age is not, the height of the student is not dependent on the marks scored by them. But here, if I tell you that I don't want this, what I want is whether probability of A given C and probability of B given C, do they have any relation? Do they have any relation or not? We are finding that height of the student and marks of the student, whether these two given age is same. So you have taken age as same. Why? Because here when we were just talking about A and B, only concern was age. That the taller students may be of higher age and that is why they are scoring more marks. So A and B may be dependent on each other. But you guys are saying no, it's independent. Anything is possible. So I have introduced another concept that given both are student is aged 8 years and scoring above average marks. Okay, this is probability A given C. Given student is age 8, what is the probability that the student is taller than the average? Now find out that whether these two events are independent or not. So something like this, we'll do an example once we solve questions. We will be coming across a lot of questions where we'll be talking about conditionally independent or dependent events. If this is actually equal to probability A intersection B given C, then we say that it's conditionally independent, otherwise it's not. Understood? Clear? Okay. Okay. Any doubt, please ask. Okay. Now let's move to the next one. Now we talk about, so you have talked about different conditional, unconditional and all those. Now we'll talk about discrete. Let's understand another word. Discrete probability function. What do you mean by discrete probability function? Discrete, the word discrete basically means that it has integer numbers, either negative, positive, whatever. It's not continuous, it's discrete. And there are finite. When you say discrete, you also attach a word finite to it. It's not infinite. possible set of numbers, possible outcomes is finite. I'll give you an example. Let's suppose I'm talking about number of shares in a portfolio. Number of shares in a different types of shares in a portfolio. Let's talk about different types of shares. Now, if I say different types of shares in a portfolio, it can only be finite. You cannot have infinite types of shares in a portfolio, right? Okay. Price of the share price. It can be infinite. You have infinite possibilities of share prices. 66.5, 66.6, 66. It can be anything. है ना? Point wise or whatever. ठीक है? तो ये discrete हो गया. Probability function. The word discrete का meaning clear है? Probability function is basically it gives a probability for each outcome. So what happens that you make a function and that function helps you give probability for each outcome. Okay, it helps you give the probability for each outcome. Now I'll give you an example. Let's say suppose X is the different outcomes, different set of possible outcomes, and we have 1, 2, 3, 4. These are the 4 possible outcomes, and the probability function, I'm writing it as PF, is X by 10. Okay, it's similarly writing X given X is equal to X by 10. Probability of X is X by 10. X is any outcome from 1, 2, 3, 4. These are the possible. It's basically, this is the event space. Okay. Now, if I'm asking you, what is the probability of outcome 3? What is the probability of outcome 3? So, X equals to 3. कैसे लिखोगे? X की जगह पे you'll put 3. 3 by 10. What is the probability of outcome? 1. 1 by 10. And if you add for all the events 1, 2, 3, 4, if you add the probability function, this will be 1 by 10, 2 by 10, 3 by 10 and 4 by 10. It always gives you 1. It should always gives you 1. So probability function summation, this is the symbol for summation of the probability function for all x. For all x, this is the symbol for all. ठीक है, ऐसे करके ऐसे करते हैं. For all x is always equal to 1. Got it? 1 या फिर 100% भी बोल सकते हो. Same thing. Clear? चलो, let's move to the next one. Let's understand the word joint probability. इसके लिए we'll take an example. ठीक है, तो आप लोग लिखना स्टार्ट करो. Let's suppose we are considering लिखो an employee at ABC Limited, an employee at ABC Limited earning more than rupees 50,000 conditioned on the level of education. Conditioned on their level of education. There are 3 levels of education. I'm just writing it down like this. No degree, maybe only there is no particular degree that the employee has done. Bachelor's degree, and then we have higher than bachelor's degree. Okay. And we are seeing that there are 60% employees in our company who have no degree. There are 30% employees who have earned a bachelor's degree. And then kitne bache? 60 plus 30 is 90, 10% are left. So 10% students are, employees are there with higher bachelor's degree. Now, can you tell me whether these events, quickly tell me whether these events are mutually exclusive or not mutually exclusive? Whether these events are mutually exclusive or not mutually exclusive. Can any one particular employee be present in ND also and BD also? No, not possible. या तो आपका either you have no degree or you have bachelor's degree or it's higher bachelor's degree. Any one. It cannot be like you are having two. So that joint part is not there. It's 3 separate events. So it's mutually exclusive. Where there is one more word that we study is exhaustive. Mutually exhaustive. Exhaustive means that all the events, exhaustive means that all possible events are covered. Basically, all the events when they add up to 1. इसके अलावा और कोई event नहीं हो सकता. There cannot be any other event possible. So, when you are taking these 3 categories and you are saying all the employees, 100% employees are either ND, BD or HBD, nothing else is left. So all of these are mutually exhaustive as well. What do you mean by mutually exhaustive? Mutually exhaustive basically means that you have covered all the possible categories. There is no other category left. Clear? Understood? ठीक है? When you add this up, probability ND plus probability BD plus probability HBD, it gives you 100%. ठीक है? Now, when you say that when you have conditional probability and unconditional probability, when you multiply, you get joint probability. What is a joint probability? Let's say suppose I want probability A, B. I want probability A and B happening. This is A given, this is A given B into probability B. Copy this down. This is same as writing like this. Probability A intersection B. When you see this now, this is same as probability A intersection B. You can write any which way. Just give me 1 second, Vaishnavi. I'll explain. Okay? Where is this formula coming from? I'll explain. Joint probability formula, I'll explain. Joint probability meaning probability of 2 events together. Both events. That is joint probability. You're calculating that. Probability A intersection B, A and B is probability A given B, meaning probability of A given B has occurred. Now, since you are saying B has already occurred, you need to also take probability of B happening. So it's probability of B happening multiplied by, मतलब B हो गया है, so उसका probability आप लोगे, which is this, and B is done. Now, what is the probability of A, which is conditional? B has occurred. After that, you are saying A is occurring. So, conditional A given B. You cannot write probability A into probability B. Why? Acha, one more thing. One more thing. When can you write? When can you write that this is equal to A into B? अभी हमने किया क्लास के स्टार्टिंग में. When is this possible? It is possible, but when? But when? Very good. When it's independent, when the events are independent, we say A intersection B. A intersection B. Sorry. When it's independent, कैसे बोल सकते हैं? How do you derive this? Because A given B into probability B, A given B, ध्यान से सुनना, मैंने जो second relationship लिखवाया था independent पे conditional, A given B is nothing but probability A in case of independent events. It doesn't matter ना B हुआ नहीं हुआ, it doesn't matter that A will happen or not. So probability A is independent of B. So only probability A into probability B, which is this. So this is possible in case of independence. Why? Because हम start हमेशा इसी से करते. This is always our starting point. This is always our starting point. If A and B are independent, then you move through this part. A given B is probability A only. But in case when A given B are not independent, when A and B are not independent, then you'll have to use this. Yes or no? अब बताओ यहाँ तक कोई डाउट है? Any doubt? Anyone, any doubt? So building on our example, we'll continue with the example. This is the example that we were doing. Building on the example. लिखो, लिखना start करो. This is the question or the example that you are writing. We are saying 10% of the employees with no degree of employees with no degree, comma, 70% employees with BD, bachelor's degree, just write BD, and 100% employees with higher bachelor's degree earn more than 50,000 per year. So what are we saying? ध्यान से सुनना, ध्यान से सुनना. We are saying probability employee earning more than 50,000 given no degree is 10%. Probability earning more than 50,000 given it's a higher degree, bachelor's degree, sorry, not higher degree, is 70%. And probability of earning 50 plus given its higher bachelor's degree is all the employees, 100% employees. Is this clear till here? The question is clear. Here we have in the question 3 different categories of employees. Given employee has no degree, 10% of them are earning above 50,000. Given they have bachelor's degree, 70% of them are earning above 50,000. Given they have a higher degree, all of them, 100% of them are earning above 50,000. These are conditional probabilities We also have with us the unconditional probabilities as I've given you. ऊपर में देख लो ये वाला 60 30 10. Yes. Is it clear? Quickly show me a thumbs up. Now, can you calculate the joint probabilities for me? The joint probabilities are earning 50 plus and या फिर you can write an intersection, no degree, 50 plus and bachelor's degree, 50 plus and higher bachelor's degree. I'll do it for one. What was the formula? A intersection B into AB. So here we have probability 50 plus given ND into ND, which is 10% into 60%, which is how much? 0.06, 0.06 या फिर 6%, 6%. Similarly, do for the rest. करो इसको. Next one is 50 plus and BD. So probability the person is getting above 50,000 given has a bachelor's degree is 0.7, 70% into probability getting probability the person has a bachelor's degree 0.3, which is 0.21. Again, probability the person is earning above 50,000 given higher degree is 100% या फिर आप 1 लिख सकते हो into 0.1. So 0.1 ये हो गया. These are all joint probabilities. You start off from joint probability, probability A given B into B. If it is independent, it automatically becomes probability A into probability B because probability A given B is equal to probability A when it's independent. Now from here, we derive something which is very important. We derive something called as total probability. We derive something called as total probability. लिखो यहाँ पे लिखना BIs are mutually, लिखना I'm not writing, BIs are event है basically B1, B2, B3 dot 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 ऐसे तो BI लिख रहे हैं हम. BIs are mutually exclusive and exhaustive events. If BIs are mutually exclusive and exhaustive events, then probability A ठीक है. मतलब probability of A happening given BI is an event. BI, let's suppose, are mutually exclusive, meaning union intersection nahi possible hai. Intersection is 0. And exhaustive meaning you have all the events possible covered. Iske apart from that, there are no events. Then in that case, if you want to calculate the total probability A, it is nothing but probability A given B1 into probability B1 plus A given B2 into B2 and so on. It's basically sum of all the joint probabilities. So in our example, coming back to our example, if you want to calculate probability of employees earning above 50,000, what do? You add all the joint probabilities, probability 50,000 given ND into probability ND plus, क्योंकि इसके अलावा इन तीनों इवेंट्स के अलावा there is no other possibilities. All these three are mutually exclusive and exhaustive. So probability of getting above 50,000 given ND into probability ND plus BD plus HBD, वो तीनों parts जो हो जाएंगे, if you add all these three, you will eventually get out of all the employees how many of them, or what is the probability of earning, what is the unconditional probability of earning above 50,000, which is, just add it up, 6%, 0.06 plus 21 plus 10%, है ना? This is coming as 0.37. Huh? 37% of the employees are earning above 50,000. Is it clear till here? इसको complete करो. Okay. Now coming back to our formula of joint probability, which was probability A intersection B equals probability A ठीक है. So here, similarly, if you want to take out probability A given B, you can take it out using the joint probability divided by the independent probability of B. Can you do this? Let's do it through our example. Take out probability people earning 50,000, more than 50,000, given they are from given they are from bachelor's degree. You need to take it out. ठीक है, you need to take it out. How will you take it out? How will you take it out? Probability 50 plus and BD given probability BD. This we have taken out 50 plus and BD as 0.21. Probability of BD is given as ऊपर में 30%. 0.3. This is same as writing 0.7. देख लो, getting the same answer. मतलब मैंने क्या बोला, ये हमेशा आपका स्टार्टिंग पॉइंट है, इसको यूज करके आप सब चीजें निकाल सकते हो. जो सी यस वैष्णवी.
मैम ये तो यही हुआ ना कि हम अभी जो ऊपर किए थे कि वो इंटरसेक्शन वाला पार्ट, सो दैट ए इंटरसेक्शन बी इज इक्वल टू पी ऑफ ए. ये तो वही हुआ ना अभी. मतलब अभी जो 50% की हमको दिए थे आप यहाँ क्वेश्चन. तो इट इज लाइक अभी प्रोबेबिलिटी ऑफ गेटिंग 50 प्लस इज इवेंट ए एंड दिस इज इफ वी कंसिडर इट एज इवेंट बी. सो वो तो यही हुआ ना कि प्रोबेबिलिटी ऑफ गेटिंग ए.
कौन सा, ये वाला ना?
हाँ
हाँ, ये प्रोबेबिलिटी ए है. करेक्ट. गिवन B1 आपका ND हो गया, B2 आपका BD हो गया और BN मतलब B3 3 इवेंट्स ये हमारे केस में, वो आपका HBD हो गया. ठीक है.
यस मैम.
Okay. Let's move to the last topic for today, which is Bayes theorem. Bayes theorem. Now, Bayes theorem, whatever we have done till now, okay, we have taken total probability, which is probability of A. We have done joint probability, conditional probability. Using this basically, using the information of conditional probabilities, you are actually calculating the conditional probability using other conditional probabilities, other total probabilities and all that. ठीक है, मतलब ये थोड़ा सुनने में अजीब लग रहा है. Basically, Bayes theorem allows us to use information about the outcome of one event to improve our estimates of the unconditional probabilities of another event. कुछ इवेंट्स के आपको जो प्रोबेबिलिटीज गिवन है उसको यूज करके आप बाकी प्रोबेबिलिटीज निकाल सकते हो. तो हमारे केस में हमें क्या क्या पता है, पहले तो वो देखते हैं. वी नो प्रोबेबिलिटी A इंटरसेक्शन B is probability A given B probability B. We know this. ठीक है. We also know that we can write something like this: probability B intersection A, B given A into probability A. We can also write something like this. And we also know that these two are equal. A intersection B, B intersection A are equal. So if you equate these two, what are you ultimately getting? Probability A given B is equal to probability B given A into probability A by probability B. क्योंकि इंटरसेक्शन तो सेम रहेगा ना, चाहे आप कैसे भी निकालो। ए बी है, ये इंटरसेक्शन है। So when you write A intersection B or B intersection A, both are equal. So these two are also equal. These two. उससे आप ये लिख सकते हो, वेरी इजी। ये वाला बेसिकली हम नीचे ले गए, ठीक है। चाहिए ना, क्लियर। So given you have unconditional probabilities of A and B, these are the two unconditional probabilities, and you have conditional probability of B given A. Can you calculate another conditional probability of A given B? Simple. एक फॉर्मूला से सारे फॉर्मूलाज डिराइव कर ले रहे हैं। मैंने क्या बोला, ये हमेशा स्टार्टिंग पॉइंट है, इसको यूज करके वी कैन डू एनीथिंग। सो दिस इज नथिंग बट योर बेस थ्योरम। एक एग्जांपल करके इसको हम लोग कंक्लूड करेंगे, ठीक है, ठीक है। ओके, तो यूजिंग आवर एग्जांपल हियर इटसेल्फ, कैन यू कैलकुलेट probability of BD given 50 प्लस, मीनिंग इसको मैं वर्ड्स में लिख रही हूँ, probability that employee is having bachelor's degree given he earns 50,000 more than 50,000। उल्टा कर दिया, रिवर्स कर दिया मैंने। What we had ऊपर में earlier, we were given with probability of BD and ND, HBD. We took out probability of 50 using probability law, total probability. We also had conditional probabilities, but here I have done ulta. I have done, tell me what is the probability of BD given 50 plus. तो ये using this formula, if this is A and this is B, using this formula, probability कैसे करेंगे उल्टा, 50 plus given BD, this we have with us, this we have na, this we've calculated, see, this we have calculated 0.7 into probability A, which is probability of BD, we have this also, and probability of B, which is actually probability of 50 plus, we have calculated this as well. Just put it on and get the answer. This is nothing but your Bayes theorem. 50 plus given BD we already have as 0.7, है ना, देख लो। 50 plus given BD is 30%, so BD is 30%. Probability of getting 50 plus is how much? We've calculated ना यहाँ पे total probability 37%. 0 point. Tell me the answer. That is your Bayes theorem. So when you have your other conditional probabilities and conditional probabilities, using that you can also attain another conditional probability. That's your Bayes theorem. Got it? Give me the answer quickly. 0.568. So we can say that out of all the employees who are getting above 50,000, 56.8% of them are having bachelor's degree. Can you say this? देखो कितना insights निकल रहा है, कितना insights निकल रहा है. Out of all the employees earning above 50,000, 56.8% employees are bachelor's degree. Understood? With this, we finish our probabilities chapter. You can solve all the questions now from the MCQ list, and we will be taking up one doubts class and sums class. ठीक है? Any questions? Thank you so much. Bye bye.